Hi again. So far, we have only used NumPy as a computational library, but as you are probably guessing, there are Python libraries tailored for machine learning. Two are TensorFlow and sklearn. In this section, we will introduce TensorFlow, which will be the main tool we use throughout this course. Okay, the mathematical concept of a tensor could be broadly explained in this way. If a scalar has the lowest dimensionality and is followed by a vector and then a matrix, a tensor would be the next object in line. Scalars, vectors, and matrices are all tensors of ranks 0, 1, and 2 respectively. Tensors are simply a generalization of the concepts we have seen so far. We won't get more into the mathematics. I believe that's all you need to know. Once you see TensorFlow, you will quickly realize what I mean. Okay, before introducing TensorFlow, it'll be nice to take a minute and explain why it is a good choice. We will do so by comparing it to sklearn, as they are two of the most popular libraries, and most other machine learning courses are based on sklearn. Right. You probably know it, but Google is a leader in machine learning. It is also one of the great innovators in the field because of the Google Brain team. As machine learning was developing, Google needed better programming methods to suit their needs. That is why they developed the TensorFlow package for internal use. At the end of 2015, Google released TensorFlow to the public. Now, it is probably the leading library for neural networks, including deep neural networks, convolution neural networks, and recurrent neural networks. One of the biggest advantages of TensorFlow is it uses not only the CPU of the computer, but also its GPU. This is crucial for the speed of the algorithm, as, in this way, TensorFlow utilizes much more computing power. Recently, Google furthered this trend by introducing TPUs, or Tensor Processing Units, which improves performance even further. TensorFlow is one of the cutting-edge technologies available right now and is likely here to stay. We said an alternative of TensorFlow is sklearn. If you have done any machine learning but haven't used TensorFlow, you are probably familiar with the scikit-learn or sklearn library. It is very powerful and widely adopted. However, sklearn does not offer the same functionality as TensorFlow regarding neural networks. Having said that, we can make the opposite point for other fields of machine learning. In the presence of problems, such as k-means clustering and random forests, sklearn or MATLAB could be a better fit, even though TensorFlow started to make way. That is especially true when it comes to preprocessing, as we will see later. This course focuses on neural networks. We aim to provide you a deep understanding of neural networks. Instead of scratching the surface, we decided to go deeper by introducing TensorFlow. In the lessons you will see next, we will do just that. We will start by introducing TensorFlow's underlying logic. Then we will create the same minimal example, but this time using the new logic. We will continue introducing machine learning theory and its implementation through TensorFlow. It is very important to know the machine learning theory is the same for both TensorFlow, sklearn, or whatever package you are using. The only difference is the underlying code you'll write. That's our outline. Stay tuned.